Hi guys, hello everyone, how are you all? I hope everyone is doing well. Yes, so the topic that we are going to do today is we are going to talk about structure of atom, a very important topic from structure of atom, that is Bohr's model of an atom. So that's what we are going to discuss today, and I hope all of you are going to get a lot of benefit from this topic, because for sure you can expect one question from this topic in your uh, any of the like school exams, or as well as your competitive exams. So you can relate, this topic is very important, so everyone should make sure that this topic you should know, okay, and that too in detail. So before starting with the topic, I know those who are new here, all those new learners, they are curious to know about their chemistry educator. So guys, I am Manisha Rani, your chemistry educator at Unacademy, and I have enriched 5 years of experience in both online and offline teaching, and I have done my masters from NIT Warangal and bachelor's from Delhi University. I have cracked IIT JAM, CSIR NET and GATE. I have given best ranks through my students, and I am a plus verified tutor, guys. Yes, now talking about the class information, so you guys all can get to know about our classes. You can get all the information, as well as you can get all the notes, all the books, all the materials. How? If you will be joining my Telegram channel. So how you can join it, guys? It's very simple. You can join it, yes, you can join it with the help of this barcode which is there on the screen, or you can join it via link. Okay guys, very good. Now we have to know a very important information. Just like the way we have a classes on YouTube, the same way we have classes also on our Unacademy platform. Now, what are the special points about our special classes? So the first thing is you can learn from your favorite educators for free. You can engage with educators via polls. You can clear your doubts in the live special classes. So there are so many benefits of the special classes. Now, what is the special class timetable, guys? Just for your information, that 18th July we had a special class. On that we discussed all the numericals related to atomic structure. Now on 25th July there will be a special class which is there on modern periodic table. We'll be learning all the tips and tricks that how you can learn, yes, how you can learn the modern periodic table in the best way possible. And also guys, we'll be learning on 29th July about the hydrogen bonding. So this is our special classes schedule. Now talking about why you should take our Unacademy subscription, guys, because there are so many benefits for it. Now talking about few of the benefits, what and all are those? So the first thing is you can learn live from the comfort of your home. You don't have to step out anywhere. You will be learning, yes, from the top educators of India on a single platform, and you will be getting also the unlimited access to all the courses. There will be regular doubt clearing sessions, guys, and also will be doing the exhaustive coverage of syllabus. There will be a complete mentorship and guidance throughout. You will be getting the study material in the PDF formats. There will be a practice test given, live test series will be there, and there are the various batch courses according to the requirement. So Unacademy Plus subscriptions, they are already at very affordable price, guys. Yes, but before that, hi Siddhi, how are you? So before talking more about the classes, I want to celebrate the achievers of ISC class 10. So we have a Arpit Tiwari who got 98.8%. We have Sneha who got 97%. Yash 96.8%. So Chinmay 97.2%. So we have, yes, all these are our achievers, and they were studying from us and they have got a really good marks. I hope you guys also will be getting a really good marks, and you will be getting a conceptual knowledge too. It's not only about marks, it's also about the concepts, that how you learn it, how much you know about the concept. So that information also you are going to get completely along with the marks. So okay Siddhi, this is your first class. So what we are going to do today, Siddhi, we'll be talking about Bohr's model of an atom, which is a very important topic. And if you will be learning this topic, it is going to benefit in your school exams, in the competitive exam, everywhere. And this is actually a very interesting topic. So that we are going to do. Now let me tell you guys that Unacademy prices, they are already at very affordable side. But yes, today is the last day to enroll for our Plus subscription, because Plus subscription has a lot of benefits, guys. You will be getting the complete mentorship and guidance throughout. You will be having regular classes. Yes, we have a different batches going on for class 11th and 12th, which I'll be giving the information at the end of the session. So yes, today is the last day in which you can use my code, which is MRIS10, and you will be getting instant 20% discount, guys. So you should definitely go for it. Yes, very good. So without wasting the time, guys, now let's just talk about our topic which we have to study, that is Bohr's model of an atom. Right, so Bohr's model of an atom we'll be learning, but before that, let's just discuss what were the developments which lead Bohr to develop a model of an atom. So what do you have to know? Developments leading to the Bohr's model of an atom. Let's just discuss that. So what were the developments? Yes, Siddhi, what were the developments leading to the Bohr's model of an atom? So I'm sure you must have studied about Bohr's model of an atom in your lower classes also, but here it is going to be completely different as in, like, the basic stuff is going to be the same thing, but we'll be here talking in more depth. We'll be learning the things in more depth and we'll be understanding completely. So first thing what we'll be knowing, that developments leading to the Bohr model of an atom. So developments leading to the Bohr's model of an atom. So there were actually two developments, guys, which played a very important role towards the development of Bohr's model of an atom. So the first development is dual nature or character of electromagnetic radiation, EMR, which is nothing but electromagnetic radiation. Yes, and another one is nothing but, guys, the experiment results that were obtained due to the atomic spectra. Like, many of the scientists, they were actually studying about the atom. Yes, many of the scientists, they were studying about the atom, so they were getting different spectrums, different analysis they were doing, so they were getting that different results. So on the basis of that also, Bohr actually compelled to prepare a model of an atom. So the another one is experimental results regarding what, guys? Experimental results regarding the atomic spectra. So regarding atomic spectra. So these two were the main reason why actually Bohr developed a model of an atom, because he understood few of the things and by which he thought he can overcome the limitations of Rutherford's model of an atom. So first thing, let's just understand what is the dual nature of. No, Siddhi, you can watch from here itself. This is a completely new topic. It's not interrelated from previous topics. Okay, so you can watch from this lecture only, because we have just started with it. So there was a scientist named Bohr. So you must have studied in your previous classes, yes, lower classes, that there were so many scientists, right, who actually gave us the structure of an atom. Yes, Siddhi, you have studied that. That is, Dalton was the first scientist who gave. After that, J.J. Thomson model of an atom came. Then Rutherford model of an atom came. Yes, you have heard about these words, like these names of the scientists. Yes, tell me, Siddhi. So all these scientists, obviously they were having some limitation. So the another scientist came in the picture was Bohr, and what he did, he actually developed a model of an atom in which he discussed many of the things about an atom. He gave us an idea about the structure of an atom. Yes, in 9th grade you have studied, very good. So what we'll be doing, we'll be learning that what was the limitations of Rutherford's model of an atom. We have studied already that he was not able to explain the stability of an atom. So because there was limitations, so next model who came into the picture is Bohr's model of an atom. So with the help of what and all results actually Bohr created his model of an atom is two are main. One is the dual nature of electromagnetic radiation, another is experimental results regarding atomic spectra. So first let's just understand what is the dual nature or character of electromagnetic radiation. So first of all, what is electromagnetic radiation? Yes. Do you know, Siddhi, what is electromagnetic radiation? So as the name itself is saying, the radiation which have both electric as well as magnetic field of lines. Yes, what are electromagnetic radiation? Electromagnetic radiation are nothing but when, yes, for a radiation you have both field of lines, electrical and magnetic field lines, and they are perpendicular to each other. That is called as electromagnetic radiation. But how you get a electromagnetic radiation, let's just understand that first. Yes, so electromagnetic radiation, what is that first we'll be learning, and then we'll be learning about what dual nature it tells, or what is the meaning of dual nature. We know that dual means, like we must have heard this term, dual SIM. I have a dual SIM phone. So dual SIM means what? That it can have a two SIM. So same thing you can relate. So dual nature of electromagnetic radiation means electromagnetic radiation shows dual nature. What is that dual nature we'll be learning, but before that we'll be learning what is electromagnetic radiation. So what you have to know, it is when electrically charged particle, so if you have any electrically charged particle, so when electrically charged particle, yes, moves under acceleration. What happens when electrically charged particle moves under acceleration? What it do then? Yes, it creates, so it creates, or we can relate, alternating electrical and magnetic field lines are generated. Electrical and magnetic, yes, fields are generated in the form of waves. What? In the form of waves, and that is called as electromagnetic radiation. So if you have any electrical charge particle which is moving under acceleration, so it have a alternating, yes, it have a alternating, like we cannot make a perpendicular exactly, but you can relate that. So they have alternating electrical and magnetic field lines which are perpendicular to each other. So like that you can relate. That is called as electromagnetic radiation. Yes, very good. Now what is the dual nature of electromagnetic radiation? So dual nature of electromagnetic radiation means nothing but, yes, dual nature of electromagnetic radiation is nothing but that your EMR. So we'll be writing in short form about electromagnetic radiation as EMR. So EMR shows your electromagnetic electrons. Yes, obviously electrically charged particle like electron also you can relate. So when it will be moving under acceleration, so it is going to behave as a wave as well as particle. So the dual nature that we talk about, it means what? Your electromagnetic radiation, any charged particle under acceleration can show two types of behavior. So EMR shows, yes, EMR shows two types of behavior or two types of nature. Yes, first is wave nature and another is particle nature. Okay, Siddhi? So EMR shows two types of nature. One is wave nature, another is particle nature. What is wave nature? Yes, what is wave nature and how it shows wave nature, we'll discuss that. But before that, we'll be discussing about some of the characteristics of a wave. Then only we'll be able to understand what is the wave nature of any electromagnetic radiation. So let's just discuss first quickly what are the characteristics of wave. So what is wave? Anyone knows? Yes, tell me everyone. What is wave? So don't tell me the wave like which we see in the sea. Yes, the waves that we see in the sea. But yeah, like how we can define a wave, that you must have studied in the physics also. Yes. Tell me everyone, what is the meaning of wave? So wave is nothing but, it is, yes, it is a very simple thing to relate. So when we talk about a wave, what we talk about its oscillation. So when a, yes, so when a moving object, right, so when you have a moving charged particle under acceleration, it moves, yes, in a way that it shows crust and trough to a line of propagation where it starts. Crest and trough means crest is the height of the wave and trough is the depth of the wave, like where it is moving. So what we can understand, it's very simple. Wave is nothing but wave is something like which moves in crest and trough manner, means height, depth, height, depth, height, depth, like that, right? So easiest way to understand. Now characteristics of wave, what and all things we have to know. So we understood that any wave will be talking about, so it will be having, yes, a point of propagation, means from where it starts, and how it will be moving. It will be moving as height then depth, height then depth, height then depth. Yes, what we can relate, it will moving as height, depth. Correct everyone? Very good. So characteristics of wave, what we'll be learning. So the first characteristic is nothing but what is, yes, what is the amplitude of wave. Tell me Siddhi, do you know that? Everyone tell me, what do you mean by amplitude? Yes, anyone knows what is the amplitude of wave? So we'll be learning about some terms regarding wave, so that we'll be able to relate with the wave in a better manner. Yes, like we can relate with the wave characteristics in a better manner. So tell me everyone, anyone knows what is amplitude? So amplitude is nothing but it is the height of crust or depth of trough. Or you can relate that it is the height of crust or depth of trough. What I can relate over here is very simple. I can consider what are crust. So the crust are which is above the line of propagation, like from where the wave started. So these are my crust. Okay, what are the troughs guys? Yes, the troughs are the depth one, which I can relate, which is here I can talk about. So this is my trough. Now what we can relate over here, the height of crust is called as amplitude as well as depth of trough. So what are my crusts? Crust are the one which is above the line of propagation. So we can consider as these are crust and this is trough in a way. Now what is the height of crust or depth of trough? That is considered as to be amplitude. What is this? This is your amplitude. Okay, we'll be learning about all these terms. So this is amplitude. Now we have some more other terms that we can relate, that what is the meaning of oscillation. Oscillation means when one crust and one trough gets completed, we call it as oscillation. What is wavelength, wave number? So all those terms we have to know. So the first term that we'll be learning over here, yes, the first term that we'll be learning over here is nothing but what is, yes, amplitude. So what is amplitude guys? Yes, it is defined as the height of crust or depth of trough. What you can relate that? Yes, it is defined as the height of crust, defined as the height of crust or depth of trough. It is defined as the height of crust or depth of trough. Very good. How we denote it? We denote it with the symbol A, capital A. Okay. Now the second term which we'll be learning is very important guys, which is nothing but wavelength. What we'll be learning guys? We'll be learning about wavelength. You have heard about it? Siddhi, everyone, do you have heard about what is wavelength? Yes? Tell me guys. You have heard about wavelength, what it is? So wavelength is nothing but it is the distance between, yes, it is the distance between two consecutive crust or troughs. It is the distance between two consecutive crusts or troughs. Yes guys, it is a distance between two consecutive crusts or trough. Like if you will see that here you have a two crusts, in that what will be the distance? That is considered as the wavelength. Wavelength is the distance between two consecutive crusts or trough, like that you can relate. And what is wavelength, like how denoted it is denoted with the sign, yes, lambda. It is denoted with the sign lambda, and that is called as wavelength. Now how we represent wavelength we understood. Now what is the unit of wavelength? So it is generally measured in Armstrong. Yes, it is generally measured in Armstrong or nanometer. So can anyone tell what is 1 angstrom equal to? So 1 angstrom is equal to 10 to the power minus 10 meter, and it is also equal to 10 to the power minus 8 centimeter. And 1 nanometer is equal to what? Can anyone tell? It is 10 to the power minus 9 meter or 10 to the power minus 7 centimeter. Very good, easy. So wavelength, it is a distance between two consecutive crusts or trough, and it is generally measured in angstrom or nanometer. Now talking about the next term which we'll be learning is nothing but what is the frequency. Anyone knows what is frequency? So frequency symbol is nu. What is the symbol of frequency? Nu. And how you can define it? It is nothing but it is the number of waves. What is that? The number of waves passing through a reference point. Yes, in 1 second. So the number of waves passing through a reference point in 1 second. Reference point in 1 second is called what, guys? 1 second is called frequency. Like suppose you have a wave, and what you said, you consider this as a reference point. So I can make it again. What you can relate here, guys, suppose I have a wave and it is passing. So what I considered, because whenever you will be having, it won't be single wave. So suppose this I consider as my reference point. So to this reference point in 1 second, how many waves are passing? That you will be considering as a frequency, which you denoted with the dancing V, which we call it as nu. What we call it as, guys? We call it as nu. Okay, so it is nothing but it is the number of waves passing through a reference point in 1 second. Now what is the unit of it? Tell me everyone, Siddhi and rest of the people. Yes. So what is the unit for it? So it is measured. So its unit is equal to hertz. What is that? Its unit is equal to hertz. How we denote it? We can denote it with the symbol Hz. Yes. Or we have also one more unit, which is cycles per second. What is that? Cycles per second, which we can also relate it as CPS. So the unit of frequency is hertz or cycle per second. And remember that 1 hertz is equal to 1 CPS. So if you have to convert any time, you can relate that whatever is the value in hertz, that only is going to be there in the CPS, that is cycle per second. Now talking about the next one, the next term which we have to know other than frequency, yes, is we'll be learning about the fourth term, which is what is wave number. Yes, what is wave number? So wave number is nothing but it is defined as the reciprocal of wavelength. So the reciprocal of wavelength is defined as the reciprocal of wavelength. The reciprocal of wavelength is defined as what? Wave number. Defined as wave number. So wave number is equal to 1 upon lambda. And what will be the unit for it, guys? Can anyone tell? Yes, it will be very simple. Newton. What you can relate is that the lambda, the wavelength has what unit? It has a nanometer or angstrom. So what it will be? It is going to be the inverse of it. So whatever you will be using. So the wave number generally, what is the unit for it? Yes, so unit is nothing but we can use nanometer inverse or angstrom inverse, but here generally the unit that we use for a wave number is centimeter inverse, because it can be also defined as, so wave number can be also defined as, yes guys, can be also defined as the number of waves. What it can define as? The number of waves, which can be accommodated, in what, guys? Which can be accommodated in unit length, and that is usually 1 centimeter. In unit length, usually 1 centimeter, and that's what we can understand. So I hope everyone understood what is wave number. Tell me guys. Yes everyone. Yeah. Okay. So the next term what we'll be learning is, we'll be learning about one more term which is important for us to know, which is velocity. So can anyone tell what is velocity? It's very simple. Yes, and which we denote with the C. What is velocity guys? Yes, can anyone tell what is velocity? Yeah. So velocity is nothing but a very simple way we can define it is the distance traveled by a wave in 1 second. Yes. So the distance traveled, because we have to talk in terms of the wave. So that way only we have to answer. So the distance traveled by a wave in 1 second. So by a wave in 1 second is called velocity. What is velocity? The distance traveled by a wave in 1 second. And what is the velocity of light guys? Yes. What is the velocity of light? Can anyone tell? So there is one formula first of all you should know, that speed of like C is equal to mu into lambda, means frequency into wavelength. Now speed of light is fixed, but what is that? 3 into 10, so which we denote with C, and which is also we consider as velocity of light or speed of light, which is 3 into 10 to the power 8 meter per second. What is that? 3 into 10 to the power 8 meter per second. Clear with it guys? Very good. So remember that the velocity of all types of EMR in space or in vacuum is same, and it is equal to the speed of light or velocity of light. So remember that velocity of all EMR, yes, velocity of all EMR, all types of EMR in, so all types of EMR in space or in vacuum, EMR in space or in vacuum, is same as speed of light, or same as speed or velocity of light. Speed or velocity of light. Correct guys? Simple. So this we have understood. Now let's just talk about the last but not the least term. But before that I want to tell again to all of you that yes, Unacademy is offering you the instant 20% off on all its subscriptions, and what you have to know, there will be the instant 20% discount if you will be using my code, which is MRIS10. Very good. Now what we have to know, the next term, the sixth term which we'll be knowing, is the time period. What it will be knowing is time period. How we denote it? We denote it with the T, capital T. How we denote it guys? We denote it with the capital T. Now how it is defined? Very simple. It is the time taken by the wave. What is time period guys? It is the time taken by the wave. Yes, for one complete cycle. Wave for one complete cycle. For one complete cycle or oscillation. For one complete cycle or oscillation. So what we can understand, time taken by the wave for one complete cycle or oscillation or vibration is called time period. And time period you can relate is equal to 1 upon, yes, it is equal to 1 upon frequency, and which you can relate easily that the unit of this is going to be second per cycle. The seconds per cycle. So what we can relate, time taken by the wave for one complete cycle is called the time period, and the unit for this is second per cycle. Very simple. Now let's just discuss about the electromagnetic spectrum, because we'll be learning about what is electromagnetic radiation. We have learned what is the wave, what is the meaning of wave, we understood that. What are the characteristics of wave, we understood. Now let's just discuss what is electromagnetic spectrum. So electromagnetic spectrum has various radiations present in it, and how we can define it. So it's nothing but it is the arrangement of various EMR, electromagnetic radiation, yes, various EMR in the order of their, decreasing wavelength, or so in the order of their decreasing, or like we can say increasing wavelength, you can write in any manner, guys. Either you can write the increasing wavelength or decreasing wavelength. You just have to write the order different depending upon. So the arrangement of various EMR in the order of their increasing wavelength and decreasing frequency is called electromagnetic spectrum. Now, which and all radiations we have? So we have, first is the radio waves, are radio waves. Then you have the microwaves. Yes, everyone, radio waves, microwaves. Then you have what? Yes, infrared. Yes, radio waves, microwaves, infrared, visible. Yes, ultraviolet. Very simple. So you have visible, ultraviolet, X-rays, gamma rays, and you have C, cosmic rays. So what you can relate, that radio waves, they have the least frequency and maximum wavelength. Your radio waves, they have the maximum wavelength, guys. What they have the maximum wavelength, and they have maximum wavelength, they'll be having the least frequency. Yes, they have the least frequency. But because why, how you can relate that, we learned about the formula, which is C is equal to, yes, C is equal to mu into lambda, correct? So can I write mu is equal to C upon lambda? So it means your frequency is inversely proportional to wavelength, yes or no? So frequency is inversely proportional to wavelength. So if I am having a radio waves whose wavelength is the maximum, so it is going to have the least frequency, guys. What you can relate, it is going to have the least frequency, and that's what we can relate. So it has a maximum wavelength and least frequency. Like that, your cosmic rays have what? Cosmic waves have, yes, the maximum, yes, the maximum frequency and least wavelength. Maximum frequency and least wavelength, lambda. So what you can relate, the spectrum contains which and all? Radio waves, microwaves, infrared, right, visible, UV, yes, X-rays, gamma rays, cosmic rays. So all these are there, and how they are arranged, you can relate that as you're going from left to right. The energy, yes, the frequency is increasing, and wavelength, frequency is increasing and wavelength is decreasing. Correct, guys? I hope everyone understood this, that for Rani, like the understanding of this, like how you can remember in the order. So you can understand one thing, that you can understand in a particular order by one mnemonic. And what is that mnemonic, guys? That is nothing but Rani Mukherjee is very useful. Yes, so Rani Mukherjee is very useful girl for, so for C you can keep any name, yes, for captain. So say what you can relate that. So Rani Mukherjee is very useful girl for captain. Why? Because she can do fight, she can do many of the things like that you can relate. So what you can understand, because she knows martial arts, say. So what we can understand, you can understand this with the help of a mnemonic. What is Rani here? Rani is nothing but is going to make you understand about the R, which is radio waves. Yes, then you have what? M is nothing but it is the microwaves. Yes, here you have R is radio waves, you have M microwaves. Then is the infrared, V is visible. Yes, U is UV, G is gamma, and yes, is very useful. X girl for captain. So you must be thinking that yes, where X has gone. So it is very useful. X girl for captain or ex girlfriend for captain. Anything you can relate, right? So it is very useful. X. Yes, ex girl, or say she was an ex employee of that. So you can relate. Yes, what we can understand. So it's very useful. Ex girlfriend or girl for captain. So we can relate that. Very simple. So I hope everyone is able to relate with the mnemonic, and you will be easily able to remember this with the help of it. Now if I talk about the particle nature of electromagnetic radiation, so this is the wave nature. Like your electromagnetic radiation behaves as a wave which has all those characteristics. Like you can define the wavelength for it, you can define the frequency for it, you can define the time period for it, and many of these terms. Now talking about the particle nature of wave. Yes, talking about the particle nature of wave, what we can relate is, so particle nature of wave is nothing but it was actually explained by the Planck's quantum theory. So the particle nature of wave, who explained it, guys? There is a theory named particle Planck's quantum theory, which actually explained us the particle nature of a wave, right? Or particle nature of what? Particle nature of electromagnetic radiation, guys, because obviously electromagnetic radiation shows a wave nature, but it's not good to say it as a wave. Like it shows a nature, but it's not completely a wave, because it shows the nature as a wave as well as particle. So particle nature of electromagnetic radiation, who explained it? Planck's quantum theory. And from that what we can learn here, guys, yes, a simple thing, that when your electromagnetic radiation is going to behave as a wave and when it is going to behave as a particle. So remember that whenever your any electromagnetic radiation originates, so it will be originating as a wave, like it will be propagating as a wave, but when it has to interact with some substance, yes, so when it will be interacting with some substance, with some object, so it will be showing a particle nature. So it's very simple. When a wave or when an electromagnetic radiation propagates, yes, when EMR propagates, shows wave nature, but when it interacts with the matter, shows, when it interacts with matter, shows particle nature. When it interacts with matter, what it shows? Shows particle nature. Correct, guys? Very good. So when EMR propagates, shows wave nature, but when it interacts with matter, shows particle nature. Now talking about the particle nature, how we can relate it. So we can relate it with a theory which I said, Planck's quantum theory. Planck's quantum theory. So obviously who gave this theory? A scientist named Planck. What he said, that whenever you will be having any radiation and the energy acquired by the radiation, will be calling it as a radiant energy. So what it said, the radiant energy which is emitted or absorbed by any body, like specifically say hot body, is discontinuous in the form of small packets. So the energy is not a whole sum, it is divided into small packets, and that we can consider as quanta. So what is Planck's quantum theory, guys? It says that the radiant, what it says, the radiant energy which is emitted or absorbed yes, the radiant energy which is emitted or absorbed by the hot body is discontinuous in the form of small packets discontinuous in the form of small packets, and that packets have a discrete energy. So small discrete packets of energy, yes, and each packet of energy, what it is called as, guide, that each packet of energy is called as quanta. Yes, Siddhi, everyone? So each packet is known as quanta. And when we'll be talking about the sunlight, we'll be discussing that quanta as a photon, right? So what it said is very simple. The radiant energy which is emitted or absorbed by the hot body is discontinuous in the form of small discrete packets of energy, and each packet is known as quanta. So what he said that energy of each quanta is directly proportional to its frequency, of radiation. So whenever you have a proportionality sign and you have to remove it, so how you'll be removing it, guys? You should remove it with the help of a constant, and as this theory was given by Planck, so the constant that we use is called as Planck's constant. So H is Planck's constant, who has a fixed value which is nothing but 6.626 into 10 to the power minus 34 joule second. And what is mu here, guys? It's frequency, and E is the energy. Yes, so energy of each quanta, it is actually directly proportional to what, guys? It is directly proportional to frequency. And when you remove the proportionality sign, what you get, guys? You get the Planck's constant, which has a fixed value, which is 6.626 into 10 to the power minus 34 joule second. And what we have to know, that the total amount of energy emitted or absorbed by a radiation, or by a body is integral multiple of quantum. Integral multiple of quantum. Correct, guys? Very good. So this we have understood. That what Planck's quantum theory says, and it said that the whatever energy is there that we get is not in the form of, yes, it is not the continuous form, it is discontinuous form in the form of small packets, which we call it as quanta. Okay, very good. Now in this only we can learn about one small effect also, what is called as photoelectric effect, which also helps us to understand about the particle nature of a matter, like the electromagnetic radiation. So photoelectric effect, what we can understand here, so photoelectric effect is nothing but, guys, it says that when an surface of a metal, yes, what you have to know, when a surface of a metal is irradiated with a frequency of, with a radiation of suitable frequency, then the electron gets ejected from it. What photoelectric effect says, when photons, so when from the sunlight we use a quanta of energy that we call it as photons. So when photons of sufficient energy, hits the metal surface, then electron comes out, yes, then electron comes out of the metal surface. Like suppose what you did, say you have a metal surface over here, and on that what you did, a light of suitable frequency you have irradiated. And what happens if it will be suitable frequency? It is a frequency which is minimum frequency required to eject the electron. Then it is going to remove an electron, and obviously it's going to be a moving electron. And how we can find out the moving electron kinetic energy? That we can find it out with the formula, that is kinetic energy is equal to h mu minus h mu naught. Now what is this? Yes, so kinetic energy of the moving electron, how we can find it out? We can find it out with the formula h mu is equal to h mu naught. So what is h mu, guys? So h mu is nothing but, yes, h mu is nothing but it is the energy of radiation falling on the metal surface, very good. And h mu naught is nothing but it is the minimum energy required to, yes, the minimum energy required to interact with the metal surface, and eject electron from it. Very good. So this is also known as, work function. Guys. It is also known as work function. And what is mu naught? Mu naught is the threshold frequency. Again, the minimum frequency of radiation which is required to eject the electron from the metal surface. Okay, very good. So I got the formula, which is kinetic energy is equal to h. I can write mu minus mu naught, or I can write what is the formula of kinetic energy. We used to study in lower classes, half mv square is equal to h mu minus mu naught you can write, or you can write half mv square is equal to h mu minus work function. So all are the formulas related to the photoelectric effect. So with this we got to know what were the developments which lead to the Bohr's model of an atom. Next class when we'll be meeting, we'll be learning more about the Bohr model of an atom, that what are the advantages of Bohr model of an atom, what are the disadvantages of Bohr model of an atom, and all these things we'll be studying. Okay, so what and all things we have studied today, guys? We studied first about what and all were the developments which lead to the Bohr model of an atom. So the developments which lead to the Bohr model of an atom were two. One is the dual nature of electromagnetic radiation, another is the atomic spectra of the different atoms which were obtained. Yes, so the experimental studies related to the atomic spectra, that was one of the thing. Then we discussed that what is the meaning of dual nature, that your electromagnetic radiation, it shows the both type of nature, that it shows wave nature as well as particle nature. When it propagates from any source, it behaves as a wave, but when it interacts with any matter, it behaves as a particle. That we understood. We understood what are the characteristics of wave. Around 6 characteristics we have studied. Then we also discussed what is the particle nature of wave, like the electromagnetic radiation. It was explained with the help of Planck's quantum theory. We got to know that. We also understood the photoelectric effect, which is nothing but when your metal, yes, interacts with the radiation of suitable frequency, it ejects the electron from it. And this is what we can know. Very good. So this we have understood. Now let me give you some information regarding our classes, guys. And what is that? Yes, so all of you should know that which and all ongoing, because whatever we are doing in these classes, we are doing good. But if you want to do in a complete order, the topics if you want to do in complete order, and also if you want to learn, yes, if you want to do the exhaustive coverage of syllabus, what you should do, guys, you should, yes, join our batches. So for class 12, the batch name is Achievers, and who and all will be taking classes for it. So So I'll be taking your chemistry classes, and this batch which I'm talking about as achievers, it started on July 6th. So I take chemistry classes over there. Lakshya sir says takes biology class. Physics is taken by Mohana Thara ma'am, and maths is taken by Rahul Bhavanani sir. Same is there for the ISC class 11 also. So all the teachers are same, and we'll be doing the exhaustive coverage of syllabus, guys. What is the benefit if you'll be taking the subscription for class 11? So if you take the subscription for class 11, guys, you'll be getting the class 12 subscription absolutely free for the classes. And you should know that Unacademy, yes, is offering you the 20% offer, right, which is applicable, yes, and which makes the prices to be very less. And what you can do is you can use my code, which is MRIS10, and you will be getting instant 20% discount, guys. What you will be getting? You will be getting instant 20% discount. Now let me introduce you about our community. Yes, so if you will be joining our community, what and all will be the benefits? So first thing, you will never miss any update from your favorite educator. You will be getting all the material, all the session notes you will be getting on the community. So you can join with the link, and you can let me know if you have any of the doubts, whatever topic we have studied. So you can let me know if you have any of the doubts related to it. Okay, so okay guys, we'll be meeting in the next session then. Thank you all of you. Bye bye. Thank you guys. Bye everyone.